Today, we're tackling a problem that seems simple on the surface, finding numbers with an even number of digits. But the real challenge lies in doing it efficiently. How would you approach this to avoid unnecessary overhead? Given an array of integers, our task is to return the count of numbers that have an even number of digits. For instance, if you have 12, it has 2 digits, which is an even count. 345 has 3 digits, an odd count. We need to tally up only those with an even digit count. A common first thought, and often the most straightforward to implement, is to convert each number to a string. Once it's a string, checking its length is trivial. We'd iterate through the array, convert each number, get its length, check if the length is even, and increment a counter. While this works, string conversion isn't free. It introduces overhead and potentially allocates new memory for each number, making it inefficient for larger inputs or performance-critical scenarios. The time complexity becomes O, n times d, where d is the average number of digits, and space is OD if we consider the string conversion. The key insight for optimization is to count digits mathematically, avoiding string conversions entirely. We can do this by repeatedly dividing the number by 10 until it becomes 0, incrementing a digit counter with each division. Each division effectively removes the last digit. We initialize a digit counter to 0 and a temporary variable for the current number. Inside a loop, as long as the temporary number is greater than 0, we increment our digit counter and then divide the temporary number by 10. Once the loop finishes, our digit counter holds the exact number of digits. Then, it's a simple modulo 2 check to see if it's even. This approach is more performant because it relies on basic arithmetic operations, which are much faster than string manipulations. Let's trace this with an example. The array containing 12, 345, 2, 6, and 7,896. We start with 12. Our digit counter is 0. 12 is greater than 0, so digits becomes 1, 12 becomes 1. 1 is greater than 0, digits becomes 2, 1 becomes 0. Loop ends. 2 is even, so our total count is 1. Next, 345. Digits counter for this number starts at 0. After first division, it's 34, digits 1. After second, it's 3, digits 2. After third, it's 0, digits 3. 3 is odd, so total count remains 1. We skip 2 and 6 as they both have 1 digit. Finally, 7,896. After 1 division, 789 digits 1. Then 78 digits 2. Then 7 digits 3. Then 0 digits 4. 4 is even, so our total count increments to 2. After iterating through all numbers, our final count is 2. This is correct because only 12 and 7,896 have an even number of digits. You'll spot this pattern when you need to extract properties of a number like its digit count or sum of digits, and efficiency is a concern. Anytime you're tempted to convert a number to a string for digit-related operations, consider if a mathematical approach using division or logarithms would be more optimal. The time complexity is O, n times log base 10 of max, where n is the number of elements and max is the largest number. Space complexity is big O of 1, constant time. This simple trick can save significant performance. Try the next problem, same pattern. If you found this helpful, please like and subscribe for more efficient solutions.